Let's look at how to add a new node to the end of the list instead of the beginning of the list. So we create a function called append that's going to take an initial pointer to the head of the list, h, so here's our list, and a new value to be added to the list. Okay, so what we want is to create a new node and stitch it in at the end of the list instead of at the beginning of the list like we did before. So again, we have to create a new node, so we allocate using malloc a new node. New is a variable that points to this new node. Okay, so malloc, size of struct node, fill in the value, set the pointer to null. Okay, so here's our new part of the list. Now we want to add this to this list. Okay, well, what we want is for the tail node to now point to the new node. Okay, but what we have is h. H points to the head node. We don't have anything right now that points to the tail node, so we have to traverse the list to find this node. So we create a new variable p here, p. We're going to point to the head node, so p is equal to h. We're going to start here. So when do we stop? Well, when we traversed the list before, we stopped when p was null. Well, if we follow through and set p equals to null, we've fallen off the edge of the list and we still don't have a pointer to this. So we need to stop right before we fall off the edge of the list. So instead of checking for p not equal to null, we check for p next not equal to null. So p points to here. If p next points to something, that means this is not the tail, and so we want to move on. So while p next not equal null, p equals p next. So we change p to point to here. This is not null, so we change p to point to here. P next is null, so we stop there. Okay, so now p points to the tail node of the list, and now we're ready to change this link to go here. So this link is p next, so we say p next is equal to new. We take this value and we copy it into here. Now this node points to the new node that we created, which is what we wanted. Okay, h is still the head of the list, so our new list starts at h and goes through all these nodes and ends up here, and that's the end of the list. So we return h. That's our new list. But there's a problem. What if originally our list was empty? So if h were equal to null and none of these nodes existed, we would return h and we would create this node, and first of all we would get into trouble here because p would be null and p next would be a segmentation fault. Whenever we have a null pointer and we try to follow that pointer, we're going to get a segmentation fault. So this is not correct yet. We have to account for the case that h, when it's given to us, might be empty. H might be null. So how do we fix that? Okay, so h is null, and what we want is to again create our new node and then make h, instead of be null, we want h to point to the new null, the new node here. So, a different color. Right? That's what we want. So here we create the new node, we initialize it, we set its pointer to null. We have a special case. If h is equal to null, right? So if h is equal to null, which it was originally, then the special case is we just want new to be this new value of h. So we want h equals new. If that's not the case, then we're back where we were before, where h points to a node and we create p and we follow p. Right? This is the same as it was before. It's this if condition that's different. So now we either do this, which is this case, or we do the loop that we had in the previous board, and that was the case when H was not null. In either case, H still points to the head of the list, whether it's the new head or the old head. That's what we return. So this code will work, and it accounts for the case where H is empty or the case where H is not empty.